We're delighted to have a great topic and a great guest speaker this morning from Ohio State University. She'll be officially introduced, but she's already got a fan club over here at her table, so you are in for a treat. We are delighted, of course, to host again this regular event, thanks to our sponsors, Premier Bank. Would our Premier Bank representatives please stand? The next time we do this, there will be West Bank, which sounds really, I don't know, interesting, ride. It gives you a sense of mystery, and I know you like that. But spring is well underway, of course, on our campus. We're looking forward to graduation. On May 10th, we have a good population of students this spring. In fact, our colleges of business and pharmacy have seen an increase this spring in their enrollments over the last two spring enrollments. We're very pleased by that. And just so you know what your university's most popular majors are, because I know, talk about the University of Findlay at every opportunity and brag about us. I'm assuming you do, because I don't know why you wouldn't. So just so you have some facts under your belt, our most popular undergraduate majors are animal science, pre-veterinary medicine, business administration, equestrian studies, and pharmacy. And our most popular graduate majors are the MBA, Masters in Health Informatics, Doctor of Physical Therapy, and Masters in Education. So please commit that to memory. We have 30,000 alumni of record living in 72 countries. Most of them are in the United States, but 72 countries host and are home to our alumni. And of course, we have much to be proud of. Our student who will present the invocation, lead us in the invocation this morning, is Amber the Great, Amber Robeson, who has finished her undergraduate degree in 3 years. She'll be graduating in May 10th, and moving on to Mississippi State University for veterinary school, where she will learn to speak the way I talk. So Amber and I are good friends. But Amber has done a remarkable job of hard work and great grades and is looking toward a wonderful career. And I want to add that she was able to finish her degree in 3 years because she took 58 hours in College Credit Plus, most of that through the University of Findlay's College Credit Plus program for high school students. So it saves her time and money. And in fact, we have among us today the president of the National Association of College Credit Plus, Chris Denneker, Dr. Chris Denneker, our own. So no wonder CCP is so powerful. It's got great leadership, and the University of Findlay hosts probably the largest population of CCP students. So we're very proud of that. We are here to help students like Amber succeed at an affordable pace. So Amber, please come forward and offer our blessing.
Good morning, everybody. My name is Amber Robeson, and I'm a senior pre-vet animal science major with a double minor in chemistry and biology. It's an honor to be here with you today. For a quick background on myself and my relationship with the University of Findlay, my dad is a UF alum who graduated in 1996. I started my career here my junior year of high school, where I took College Credit Plus courses through university, which allowed me to complete 58 credit hours, which is roughly 2 years of college before I graduated high school. Now I am able to graduate a year early, so I'm graduating this spring at the end of my 3rd year, and I have just been accepted to veterinary school, where I will attend Mississippi State University College of Veterinary Medicine to continue to make a difference in the world. On campus, I am very involved in campus ministries, where I'm the worship band vocalist leader of Christian Veterinary Fellowship, was a previous girls group Bible study leader. I am involved in DTA, the Agricultural Honor Society, Tri Beta, a Biological Honor Society, Mortarboard, National Honor Society, and more. I am also a part of a research group under Dr. Zulu, where we are currently researching HeLa cells and how they're affected by a drug we made to possibly kill cancer cells. Overall, the University of Findlay has given me opportunities and experiences that have helped me become a well-rounded individual, and I can never imagine myself being anywhere else. Today, we are privileged to hear from Jenna Kline, a PhD candidate in computer science at Ohio State University. Before we begin, let us take a moment to reflect and invite wisdom and guidance. Will you bow your heads and pray with me? Heavenly Father, we thank you for your gift of this day and the opportunity to gather and learn from Jenna Kline, whose work beautifully blends innovation with a deep care for your creation. Thank you for the minds and hearts you've inspired to explore new ways of preserving and understanding the world around us. As Jenna shares her experiences, we ask that you open our minds to the possibilities that come when technology and compassion work hand in hand. Help us to see how the tools of today can serve the needs of tomorrow, especially in caring for the creatures and ecosystems you have entrusted to us. Grant Jenna clarity as she speaks, and bless her continued efforts to enhance wildlife conservation through science and service. May we be inspired to use our own skills, whether in science, leadership, or community, to make a positive impact wherever we are called. Thank you, Lord, for the curiosity that drives discovery and the purpose that guides it. May today's insights challenge us to think deeper, act wiser, and care more fully for the world you've made. In your holy name we pray. Amen.
Good morning, everyone. I am here with the honor of introducing our speaker today. If I haven't met you yet, I'm Ken McIntyre with University Advancement here on campus. Thank you for joining us, and again, thank you, Premier Bank, for your sponsorship. It is my pleasure to introduce our distinguished speaker, Jenna Kline, a computer science PhD candidate from The Ohio State University. Jenna's research develops AI drone technology for field animal ecology. She is integrating computer vision, robotics, and edge computing to enhance animal detection and tracking, which I think might be better said that she's transforming how we look at wildlife research. Jenna has done field work in exciting locations around the world, ranging from Kenya to the Wilds Conservation Center here in Ohio, as she studies animal behavior and diverse ecosystems. I would like to bring to the stage Jenna Kline. Thank you.
Good morning, everyone. Thank you, Ken, for the introduction, and thank you so much for having me here with you this morning. You guys have been so welcoming, and it's truly an honor to present here at the University of Findlay. So my name is Jenna. I am a PhD candidate at Ohio State, and today I'll be presenting a little bit of my research on drones and AI for field animal ecology. So like Ken mentioned, my research focus is autonomous aerial systems for AI-driven animal ecology studies. And I'll get into a little bit exactly what each of these words mean as we go through the talk. So just a quick preview of what I'll be going over today. First of all, why autonomous drones for animal ecology? You might be asking yourself. So we'll go over that. Hopefully you'll be convinced by the end of the hour. I'll go over the autonomous drone system that I've built to start to answer some of these questions, show some hopefully cool pictures of some field test results and the system performance, the implications of this work for animal conservation, as well as future research and how you all can get involved. So, drones, as you may know, can capture really high-quality ecological data in the field. This is a clip that I got in Kenya 2 years ago. We were tracking this herd of plain zebras. You might be able to tell there's a little foal right in the middle here, and we were able to capture a lot of really interesting intra- and interspecies interaction with this video. We were all very surprised when a giraffe decided to run through our scene and interrupt the data collection. So capturing this sort of unexpected event of how animals interact would have been really difficult using traditional manual methods. So some advantages of this drone data collection is that we can get very fine-grained individual behavior, see the social interactions between members of the same herd as well as other species, understand better how these group behaviors emerge. And we also get the environment and habitat conditions that these behaviors are emerging in. But it's not without its difficulties. As somebody who's done a lot of field work, I can attest that it is quite manual and tedious. I never thought I would get bored filming zebras in Kenya, but let me tell you, after 3 weeks straight, I was, I was a little tired. It's expensive to travel to Kenya, and the equipment is expensive. It's also challenging to replicate these very manual studies, and this replication makes it difficult to scale. But if we're able to solve these challenges, a better understanding of animal behavior can help us understand how habitats are changing and help us guide more effective conservation policies in the future. So with that background, my research objective for my PhD thesis is to develop and deploy autonomous navigation models powered by Edge AI. So we're able to do this analysis in real time. This will allow us to maximize our data quality while also minimizing disturbance to the ecosystem. So to that end, my background is computer systems, so I've built a system architecture to start to solve and understand these problems. So this diagram shows the essential components, and there's really three. I have the drones, of course. We have our control software, and we also have the edge devices, so essentially the laptops, the computers that we use to actually run the code. The control software is where I think it gets a little bit more interesting. This is the part of the system where we take in the video feed, we analyze it using AI, and using usually computer vision models. And then based on the analysis that we do using the AI, we can build an autonomous navigation policy to figure out where to steer the drone next to maximize our data collection quality. And I'll show a specific example in a bit. So the research methodology involves a lot of testing in simulation as well as in the field. So typically we go to Kenya at least every other year, collect the data, analyze it, see what are the problems that our animal ecology partners are really interested in solving, what data is out there, and what are the gaps. So based on that data analysis, we can refine our system and do field tests. One of the really special things about doing this research here in Ohio is that we have access to the wilds, which is the largest safari in the States. It's 10,000 acres located in southeastern Ohio, about an hour due east from Columbus. So that facility allows us to do these field tests to refine our system faster, so then once we're able to go back to Kenya, we're able to test it. So the first piece of data collection that I did for my thesis work was 2 years ago, as I mentioned. We went to Kenya for 3 weeks, and it was really a proof of concept trip. My advisor is really interested in animal behavior, specifically Grevy's zebras. They're a very endangered zebra. There's only about 2,000 left in the wild that live in this one particular park in Kenya. And we wanted to see if drone videos could give us a better understanding of what these zebras get up to every day. They live in bushy areas, so they can be hard to observe manually, using binoculars or even filming from the ground. So we spent 3 weeks in the field to really understand the social dynamics of these animals, understand what data is interesting to ecologists, and see how we could collect that with drones. So this has developed into a benchmark data set, which has been used by ourselves as well as other research groups to develop AI models to actually automatically classify behavior of animals from videos. So based on that trip, like I mentioned, it was a very manual and tedious process to go out and collect all of these videos manually. And I thought that there should be a way to automate this, right? As a computer scientist, we're always trying to figure out how can I automate the boring tasks in my life so I can focus on what's more interesting. As people who might use drones know, a lot of them come equipped with a follow me feature. So if you put your drone up in the air, you're able to click on a person or a vehicle, and the drone will automatically track you. It allows you to get really cool videos of people doing ski tricks or skateboarding tricks. And I thought, wouldn't that be great if I could just have my drone automatically follow my herd of zebras? Unfortunately, most drones do not come equipped with this functionality yet. But luckily, we do have computer vision models that can automatically detect where the animals are in the frame. So I was able to modify this follow me functionality and redefine the object of interest as the herd of animals. So in the black here, you can see the triangles drawn around the animals, and the green is the center of the camera. So essentially, we're continuously calculating where the animals are, what is the offset from the center of the camera, and adjusting our drone. So by doing this, we're able to automate some of the more tedious parts of the data collection, while also keeping the whole group in the frame, so we're able to capture this interesting group behavior that our ecologist partners are interested in. So before deploying this in the field, of course, I wanted to be very confident that it worked in simulation before I bothered any zebras with it. So the testing and simulation, I was pleasantly surprised, was able to recreate the manual flights pretty accurately. And once we were able to add the telemetry data, which includes things like what's the optimal velocity, what's the optimal altitude for this type of behavior, our accuracy improved even more. So at this point, I felt confident that we were ready to deploy in the field. So the initial tests were at the wilds. So the process went like, we would go out, locate the animals, put the drone in the air. The system would autonomously approach the animals until it was able to detect them, do the autonomous tracking, and then return when the battery was low. So the first phase of this was at the wilds in Ohio, which is the conservation center that I mentioned. It's a former strip mine, so there's also a lot of research that's ongoing for biodiversity and habitat restoration. And the Columbus Zoo also manages, I think they have about 20 different exotic species that are native to Asia and Africa. So if you haven't been, I highly recommend. It's a great outing. They have some very rare endangered species that are quite difficult to study in their native range. That includes the African painted dogs, which I have pictured here. They're very cute. They're a little scary. And they also have giraffes, and we're actually lucky enough that there's a herd of Grevy zebras here in Ohio, which are those very endangered ones that I mentioned. So the system evaluation in the field went very well. I did this testing over the summer. Whenever with field testing, there's of course always hardware issues to overcome. The drone breaks, the laptop breaks, the weather doesn't cooperate, but luckily it was right here in Ohio, so I was able to go back as many times as we needed to collect this data. So using this autonomous system, which I've nicknamed Wild Wing, we were able to collect a lot more usable data than we were manually, which I was really excited to see. So as this slide shows, the manual approach, only about 2/3 of the frames that we collected were actually usable to infer behavior. But with the automated approach, where we're really tuning the system to collect exactly the data that we need, that yield is much higher. So much more efficient use of battery, time, and resources by automating this data collection. So the next step was to go back to Kenya and test this in the field. So I was lucky enough to join a group of researchers, the Wild Drone team. It's a research project funded by the EU. So I traveled there with myself and 12 other PhD students, as well as professors and research staff. It was really great to work with them. As you can see, we had a ton of different drones to test, a ton of different projects that were running at the same time. So it was definitely a very intense week, but it was really great to be there with a bunch of other drone nerds and just collect some really great data in Kenya. Since we were there with such a big group that also included ecologists, we were able to run a lot of projects in tandem and focus on a lot of different species. They have a pride of lions at this park, which are, a few have GPS collars, so we're able to track them. So there's an ongoing project with thermal drones to actually understand how do these lions hunt at night. For obvious reasons, it can be challenging to observe animals at night. Humans aren't very well suited for that, but many animals are, and we don't know what they get up to, but now with thermal drones, that challenge becomes a lot easier. This park is also very special that they have black and white rhinos, which are very endangered. So we're investigating how can we use drones to assist the rangers in protecting these very precious species. Of course, they have zebras, which are my personal favorite. I have a soft spot for them. And they were very habituated to people, so they were nice and friendly to study, which is always great. We also had some projects studying the elephants there. It might be a little hard to see, but these are actually hippos hanging out in the water. It was very cool to see them in the wild, as well as using drones to do things like mapping the habitat so we can understand more about the environment and more about the context in which these animals live. So the next step that we're working on is scaling up these missions. So if one drone is good to collect data, maybe two are even better. And as it turns out, different types of missions are better suited for different types of tasks. For example, if we're tracking an animal, it's really good to have a bird's eye view. But for behavior, we'd really like to get the side view. If we want to have both at once, wouldn't it be great if we could coordinate the drones to do both at the same time? So this is a photo of me and some of my colleagues from Wild Drone where we were testing out some of this autonomous swarms. It's also something that we've been exploring in simulation. As you can see from this animation here, how do we optimize the placement of drones to best collect the data? The nice thing about testing in simulation is that it's much cheaper to make a mistake in simulation, right? We can test what's the most cost efficient, what's the least noisy, what's best for what particular animal that we're interested in studying, and really refine it on the computer before going out in the field. Another topic that we're really interested in is behavior adaptive flights. Like I alluded to earlier, ecologists, if they want to use these drone footage to understand behavior, are of course concerned, well, are the drones causing unnatural behavior? If so, that doesn't make for a very good behavior study since it's not great data. But if we're able to understand what behavior is natural, zebras being zebras, what behavior is induced from the drone, we can design our missions to essentially prevent spooking the zebras or bothering them. The big challenge is that, unfortunately, we cannot read zebras' minds. We don't have that technology yet. I'm sure, hopefully some neuroscientists are working on this. So untangling what is the zebra being spooked because they sense there might be a predator nearby, what's the drone. And interesting, we've also found that habituation plays a very big role. So you could have the same species, same demographic makeups in two different places in Kenya in the wilds, and they might react very differently. So being able to have this autonomous system that's able to be adaptable and meet the needs of these very challenging studies is very critical and something that I'm very excited to work on. So research implications. These autonomous drones allow us to scale our data collection. This is really important if we want to be able to start answering questions about why animals do what they do, what are they reacting to in the environment, and having these large, high-quality data sets are also very important since they allow us to train the AI models that can then allow us to analyze our data in a reasonable time. They also allow us to adapt in real time to these challenging environments, react differently depending on the species. They allow us to monitor ecosystems non-invasively, so we're not disrupting the animals and we're not disrupting the natural environment. And having better data allows us to make better informed conservation policies. So I would just like to take a moment to thank all of my funders and collaborators. This really wouldn't have been possible without the Imageomics Institute and the Icicle Institute, which are both headed at Ohio State. If you're interested in any of this research, highly recommend checking out their websites. There's a ton of researchers that are doing similar projects, as well as my partners with Wild Drone, the Wilds, and Impala and Olpejeta Conservancy in Kenya. So I've talked a lot about drones today, but this is really just a small piece of the puzzle. With all of the new technology that's coming out every day that allows us to do new remote sensing studies, there's a ton of different data sources. So another piece of my thesis is figuring out what are drones good at, what are satellites really good at, what can we use bioacoustics for. So again, just a small piece of the puzzle, and we have a very large toolbox that we can use to better understand ecosystems and animal behavior. If you're interested in finding out more, I highly recommend checking out the Wild Labs network. It's all about conservation tech, researchers, as well as citizen scientists, how to get involved and learn more. I'd also recommend checking out the AI for Research YouTube playlist. It's a playlist of different labs who are doing research in this area, just to kind of give a quick preview of some of the really cool research that's going on in this space. And I hope to add mine soon in the next few years. Great, well, thank you so much for having me, and I'd love to open the floor for questions.
Hi, I was curious, some AI surveillance, can recognize people in a crowd. I was wondering if you go back out into the field, can AI recognize certain zebras that it's seen before?
Oh, yes, if we can individually identify zebras.
Right.
Yes, so one of the really cool things about zebras and giraffes and similar species is that, yes, they are uniquely identifiable. You can think about zebras as barcodes, and we can scan them and track them over their lifetimes. For the Grevy zebras, that's one reason why we have such accurate numbers about their populations, is that we're able to photograph them and identify them. So actually, one of my colleagues at RPI is working on automating drone missions that are best suited for doing these individually identifying studies. The challenge is that you need to get really good angles on the zebras to get their shoulder and haunches. So automating that process is quite challenging. But yes, that's something that we're actively working on. Great question, thank you. Oh, so the question was the price point of the drones. So the ones that I used in Kenya recently, they're Peridinofi drones. I buy them refurbished from eBay. Those run about $300-400. And they're nice to test these autonomous missions, since if you're automating something, it's not always 100% reliable. We do have some more expensive drones. The DJIs will run you probably $3,000, and if you want to get into more experimental platforms with a GPU on board, for example, those maybe start about $5,000.
One more question. Are you aware of any research around the gorillas in Africa, the mountain gorillas, and are there issues with the trees in an environment like that?
Oh, yes. I am not familiar with primate studies specifically, but yes, it is quite challenging to study animals in very dense vegetation. I am aware of one research group in Australia that's used drones to study the koala population in trees. And with that, I believe that they do rely on the thermal drones and go based on heat signatures.
Great talk. Thanks for being here this morning. So a question that I had is, I imagine zebras and these other larger animals travel a lot of distance in that kind of environment. So what's the range of, how far can drones track these animals away from you? And are they able to monitor, migration events and, what kind of distance these animals are traveling? Can this inform that at all, or what spatial extent can this cover?
Oh, yes. So for long distance traveling, that's where these GPS trackers are super valuable to gather that type of data. For drones, usually the restriction is what license you have or what permission you have to fly. Typically you're restricted to visual line of sight, which would be about 600 meters horizontal. Essentially, you're able to still see your drone. When we were in Kenya recently, we were actually able to get permission to fly night beyond line of sight missions or BV loss missions. So that was really great, where we were able to track the animals over a long distance. So because of safety and privacy concerns, you are restricted to how much you can track the animals. For like the Serengeti migration, I'm sure some of us have maybe seen those really cool nature documentary films of, seeing the animals. So if you know where the animals are going to be, you can track them for some time. Another way that you can track animals over longer distances is by using fixed wing gliders or even manned aircraft for those type of very long distance studies.
So this is fun. You're limited in processing and battery and what can fit in a drone. Can you speak to the workflow of when you're training the model, how much processing is happening in a cloud? How do you deal with bandwidth issues and connectivity issues as the drone is taking shots, taking frames, and processing that? And where does that happen, and how does that real-time interface happen?
Oh, yes, great question. Maybe I can quickly go back to my system diagram. Okay, thanks for bearing with me. So this is where the edge devices come in. So when we're wanting to do this real-time navigation, latency becomes a real concern. So for the system that I deploy in the field, all of the compute is done locally on my laptop, which has a GPU on board. We're also looking at how can we augment the compute that we have in the field with edge devices like Raspberry Pis, so we're able to offload some of those requests to other computing devices. As far as offloading it to the cloud, typically because we're conducting studies in these remote environments, the connection isn't great. We're usually restricted to the local Wi-Fi network that the drone is running on. So we would offload the compute to the cloud for post-processing. Yeah, great question, thank you.
This is a very inquisitive table. I was curious about the zebras. So first of all, the Grevy zebras, you mentioned that they are endangered. And can you describe a little bit more about that? And also, like why or how we know that? And number two is, did you choose Grevy zebras or did Grevy zebras choose you?
Good question. So one of my very close mentors chose Grevy zebras, I think 50 years ago, and then he got me very excited about Grevy zebras. So I really benefited from his lifetime of knowledge about these species. And the first time we were in Kenya, we happened to be in the park where these endangered zebras live. So one challenge that these species have is their just the loss of habitat. We find plain zebras are more able to live alongside cattle. There's a lot of livestock in that region, and they are able to share grazing land, but it's more challenging for Grevy zebras. They have slightly different needs for water. As well as slightly different range needs. So those, as well as diseases that they're more susceptible to.
So I have a question. Did you guys try to analyze the animal behavior during rain?
If we analyze behavior during rain?
Yeah.
No, that is a great idea, and that is one big limitation of sensing systems like drones, and that's perhaps where we would want to rely more on GPS tags because, at least as the technology stands today, we can't really fly drones when it's raining. I'm hoping that some roboticists are working on solving that challenge, but yeah, we are restricted to data sets that we've collected when it's good weather. One of the nice things about flying in Kenya is it's 90% of the time it's not raining, but that 10%, yeah, they could be doing completely different behavior. I would be surprised, but we wouldn't be able to tell for sure with our drone data sets.
Your presentation talks about data. Would you give some clarification on data? What kind of data are you getting with these types of efforts with drones?
Oh, yeah, excellent question. So the two main pieces of data that this system collects is videos and telemetry files. So the videos where we're filming the animals, that's data that's very interesting to animal ecologists who are interested in understanding where are the animals moving, where are they in the landscape, what behaviors are they exhibiting, what interactions are going on between individuals, how do group behaviors emerge. And we're able to analyze a lot of that using different computer vision AI models. And then the second piece is the telemetry data. So that's data like how fast were we flying, what was the altitude, our timestamps, the GPS coordinates, basically what was the drone doing at any point in time during the mission. So that data is very valuable to me since I can see, okay, what went well in this mission, how can we improve it? If the drone makes a mistake and flies where it's not supposed to, why did that happen? So essentially system status reports so we can further refine our methodology.
I was just wondering if you thought the technology and the program you're using would have any application in studying disease transmission between and among animal groups.
That is a really good idea. I had not thought about that. Yeah, but that would be something that would be very interesting to look at. I think there might be some interesting overlaps with the animal sciences group if that's an issue with livestock, and perhaps drones might give some insight into how these animals are interacting, and if we know they get sick after, why that happened.
Okay, Thank you.
Hi, thank you so much for your talk. I'm an ecologist, and I now have like 300 new questions I want to ask. I want to go out and buy some drones, and I'm pretty sure I'm going to get in over my head pretty quickly. So what advice would you have for someone like me who, what does it take, I guess, to train a drone to follow a certain group of animals and use that data?
Well, I would first recommend you read my recent paper that tells you exactly how to do that. It's in the methods of evolution in ecology, so all the code is open source. If you do want to have a drone to autonomously track a group of animals, the Peridinophy drones are great for that, and they're fairly affordable. Their software makes it easy to interact with, so you're able to program them to carry out the exact missions that you want. If you're looking for a drone to fly manually, DJI models are great for that. They have very robust obstacle avoidance, so it's hard to crash your drone, I would say. So if you're learning, that can be helpful.
Thank you. Give me some confidence there.
What are the weight limitations for the drones that you are using? How much payload can it carry, or does it not carry any payload besides the cameras?
Great question. So for the Peridinophy drones, the only payload is the camera. For the more, I would say, the research platforms, you are able to customize the payload, so you're able to add a thermal camera if you want, things like that. There's also certain regulations if you go over 250 grams, which I think is like half a pound, or if you go above 55 pounds, so making sure that you're staying under those restricted payloads also opens up a lot more options for when you're flying and reduces the amount of paperwork that you have to submit to the FAA and all of that fun stuff.
Thank you.
some of the other applications for the research that you're looking at right now. See, I'm a golfer, and I'm thinking this would be a great way to keep from losing my golf ball on the course. That could work, but are there other things that your research could lead to, or things that you're thinking about for future?
Yes. So one thing that my research group is really interested in is exploring more how we can use some of the technology that we've developing for animal ecology and apply it to agriculture and livestock, as well as what technology is developed to manage domesticated animals and how can we apply that to our research. One project that we're very excited about at the Wilds is that they recently got funding for, I think they're solar-powered ear tags that they're rolling out to all of their ungulate herds. So we're able to track exactly where the animals are during the day. We're able to see good ground truth data. So we can better understand our camera traps really picking up what the animals are doing throughout the day, how well are our drones covering the area. There's also been some interesting work that I've heard about recently using thermal cameras to monitor pigs and farming and use that to track their health. So potentially that could be a technology that we could use to understand zebra health. So that's on the animal side. For the drone side, I'm also very interested in seeing how we can use autonomous drones to help with disaster recovery, search and rescue, using this behavior adaptive methodology to understand if people need assistance, after a flood or fire or what have you. Yeah, thanks for the question.
Sorry, that sparked another question. the AI is housed in a laptop or a computer, right? It's not in the drone itself. So you need to have a system, a communication system between that laptop and the drone. So do you use radio waves to do that? How does the drone become quote unquote autonomous?
Yeah, so it depends on the drone platform. For the bigger quadcopters, they're actually able to have a GPU on board. So we are able to house the AI model in that compute device. So we were able to fly some missions in Kenya that had a GPU on board, so we were able to track the animals in real time on board the drone. The downside is that those drones tend to be very big and expensive and noisy. So for the smaller drones, like the parrots I've been talking about, they have a local Wi-Fi signal, which communicates directly to the laptop. So that helps overcome some of the latency issues. Knock on wood, it's been pretty reliable for me, and if there is a signal loss, typically you can program the drone to either just stay in place or return to home if there's any communication issues.
On that, I've seen a bit about developments in analog processing chips as being good, great for AI because we're dealing with probabilities and we don't need quite the precision of digital. Is there any work looking at using analog to get more compute in a smaller package for something like a drone?
Oh, I am not familiar with the analog. Maybe you could give me send me a link. We could talk after. But making AI models smaller for real world deployments on the edge is a very active area of research. Most of these large computer vision or multimodal models, like if you use, ChatGPT, something like that, they're developed to be housed and run on these big supercomputing centers. And we can't bring a rack of servers out into the field with us. So figuring out what's really critical in this model, what do we need to run in real time, and kind of what's the minimal viable model that we can use to run in the field, and then we can always use our bigger models for the post-processing. But yeah, for my system, I typically use the YOLO, you only look once, convolutional neural net. It's been around for many years, and it's very streamlined, so it's very nice for these real-time deployments.
Maybe one more question? Help me to thank our... Yeah, you can stay here for a second. All right. Well, before we depart, I would be remiss if I did not mention that the University of Findlay is in the midst of its Day of Giving. I don't know if you've seen anything posted on that, but it's a very special moment for us. Our annual philanthropic event is highlighting gifts to the Findlay Fund, which help us change student lives, make education more affordable, and enrich the student experience. In the last 24 hours, we have had over 300 donors make gifts that have totaled $131,000. So we're very excited about that. The support of our alumni and friends like you is what helps keep private in our private higher education. And we thank you for believing in the University of Findlay and in the talent of our students. And finally, just a quick reminder for those of you who have not seen it yet, our next Fridays at Findlay speaker series will begin again on May 6th, and we will have as a speaker Sam Hornish, the winner of the Indianapolis 500, or Indy 500, and three-time IndyCar Series champion he's from the Northwest Ohio area, and he will speak on life lessons from the fast lane of auto racing. So we hope to see you all there. Jenna will be around for a little bit here. A few students that are in the area, faculty members, if you have some questions, community members, she'll be glad to take those at the table up front.